Hello and welcome. Today, we're diving into something really fascinating, a new architecture for AI that could potentially change the game. It's called the Sim1 framework. All right, let's get right into it.
So the AI revolution is obviously here, but there's a huge problem nobody talks about enough. It's on a collision course with a global energy crisis. You know, every amazing model, every single search query, it's all fueled by a staggering amount of power. The source material paints a pretty scary picture. AI's energy appetite is doubling every 6 to 12 months. Think about that. By 2030, it could be gulping down as much as 10% of the world's entire electricity supply.
And to put a finer point on it, look at this number. That's the energy it took just to train the GPT-3 model. That's enough juice to power 120 homes in the US for a whole year. And, as these models get bigger and better, that number is just going to go through the roof. This just isn't sustainable. So you have to ask, is there another way to do this?
Well, to solve a problem this big, you can't just keep doing more of the same. It takes a total rethink of the whole system. You need an architect, someone who saw this crisis coming from a mile away and actually had the vision to build a different path forward.
And that brings us to this guy, Daniel T. Sasser II. He is the architect who's making a bold claim that the future of AI isn't about more raw power, it's about smarter, more elegant design. And he didn't just talk about it, he built a framework to prove it.
Now, Sasser's perspective comes from decades in the trenches. We're talking 20-plus years as a systems design engineer, an AI researcher, a founder. He understands these complex systems from the inside out. He's had a front-row seat watching this brute force approach to AI become more and more of an energy hog.
So that leads us to the absolute core of his solution. See, this isn't just about finding more electricity or making computer chips a tiny bit more efficient. No, this is a whole different philosophy about how you even begin to build an intelligent mind.
This quote from the project's own GitHub page, it just nails the problem, doesn't it? The way we're doing it now is just a mad dash to scale up, throwing more and more power at the problem, and what we get are these powerful but totally unpredictable and ethically shaky systems. Sasser's framework offers an alternative. It's not about brute force. It's about what he calls governed cognition.
And at the very heart of this philosophy, you'll find these, the 5 laws of cognitive governance. You can almost think of them as a constitution for an artificial brain. They make sure that intelligence is built in structured layers, that it understands context, that it improves its own work through iteration, that it remembers things consistently over time, and, most importantly, that real intelligence emerges from smart coordination, not just from raw, untamed power.
This slide just lays it out so clearly. On one side, you have the current way, brute force AI. It's like a power-hungry tornado, chaotic and incredibly wasteful. On the other side, you have governed cognition. That's a well-oiled machine. It's predictable, it's efficient, and you can actually look under the hood. The Sim1 framework is all about building that machine. The question is, how does it actually pull it off?
Okay, so we've talked about the why. Now let's get into the really cool part, the how. It's time to peek inside the Sim1 architecture and see the nuts and bolts that make this whole philosophy work. So from a bird's eye view, the framework is like a sophisticated orchestra. It's made up of 9 very specific protocols. Think of these as the strict rules of the road, and 5 cognitive agents, which are like specialized workers. So instead of one giant model trying to do everything at once, Sim1 splits up the thinking into separate, manageable jobs.
You can really think of it as a cognitive assembly line. It all kicks off with the ideator, which brainstorms the initial ideas. Then, the drafter comes in and creates the first version. That gets passed to the reviser to get polished up. Then, the critic acts like a quality control inspector, checking the work before the summarizer puts the final shine on it. See, quality is baked right into the process, not just checked at the end.
And look, this isn't just a cool idea. This is actual performance data. This chart here shows us memory operations, how fast the system can store and pull up information. And with response times under 15 milliseconds, that is exceptionally fast. But this isn't just speed for the sake of speed. This kind of deep optimization is really the first critical step in cutting down on wasted energy and computation.
And it's not just fast, the system is also incredibly scalable. As you pump more data into it, the processing time goes up in a perfectly straight, predictable line. With a lot of brute force systems, that line curves up and up, leading to these insane spikes in cost and energy. Linear scaling like this, well, that's the hallmark of a really efficient architecture, one that's designed to grow without collapsing.
And here's the last piece of the performance puzzle, memory usage. And again, look at that, another perfectly straight line. This just proves how disciplined the system is. There are no memory leaks, no bloated processes wasting resources in the background. It's lean, and it's lean by design. It's this combo of speed, scalability, and efficiency that makes the whole thing work.
So, let's bring this all back around. We started by talking about this massive energy crisis brewing, all thanks to brute force AI. What the Sim1 framework does is offer a real, data-supported solution to that problem.
And this number could change everything. The documentation claims that the Sim1 framework cuts energy use by an average of 65% compared to the traditional models. Now, that is not a small adjustment. That's a massive leap in efficiency. It directly addresses that huge energy problem we started with.
And the knock-on effect of that efficiency is just profound. The documentation states that this level of optimization makes it possible to go after advanced AI, even AGI, using the hardware we have today. It means we don't have to wait for some far-off theoretical tech like quantum computing. This could literally democratize the future of AI.
Which leads us to a really provocative question. If you can get this kind of performance, this kind of efficiency and control just through intelligent design, does that mean we're at a turning point? Could this be the beginning of the end for the whole brute force approach that's been dominating the industry for so long?
I'm just going to leave you with this really powerful statement from the framework's own guide. It argues that the future isn't about more power. It's about smarter architecture. A future where intelligence is governed, where it's efficient, and where it's transparent. The Sim1 framework gives us a bold and fascinating blueprint for exactly that future. Thanks for tuning in.